All right, good morning. Everyone signed in on both sheets, please. Okay. Quick safety meeting. Ergonomics. Ergonomics is a science concerned with the designing and arranging things that people use so that people will interact with the environment most effectively and safely. Ergonomics means arranging the environment to fit the person. On the construction worksite, ergonomic principles are being used to help adapt the job to fit the person, rather than force the person to fit the job. Redesigning the job to fit the worker can reduce stress and eliminate many potential injuries and disorders associated with the overuse of muscles, bad posture, and repetitive motions. As a construction worker, your hands, wrists, arms, shoulders, backs, and legs may be subjected to thousands of repetitive twisting, forceful, or flexing motions during a typical workday. Many construction jobs can expose you to excessive vibration and noise and eye strain, repetitive motion, and heavy lifting. If machines, tools, and the workflow are poorly designed, they can place undue stress on tendons, muscles, and nerves. In addition, temperature extremes may aggravate or increase ergonomic stress. Your ability to recognize ergonomic problems on the construction site is the essential first step in correcting these problems and improving construction worker safety and health. The three most important issues related to ergonomics for construction workers and ways to control them are listed in the table below. Back safety and lifting. How to control that is practice proper lifting techniques, get help with large loads, and use material handling equipment. Equipment and tool vibration. Use only the force necessary to perform the job. Hold and use tools properly. And rotate tasks and take breaks and tasks during the workday to avoid vibration for too long a duration. Repetitive motions. Perform tasks following proper job procedures at all times. Select the right tool for the job. And rotate the tasks you perform during the workday to avoid a single type of repetitive motion for too long a duration. Any questions on ergonomics or anything we can do to help you out in the field to make sure that you are protecting your back, your gut, everything else? Good. Wonderful. All right, so we're going to be watching the Dawn Wrap video. For those of you who have seen it, watch it again. For those of you who haven't, please take note. Okay, so how do you turn the volume up on this thing? On the shift keys. Where's the shift keys?
Gas furnace to propane.
Okay. All right.
So the first thing we're going to do is remove the manifold with the burners, and we're going to remove the burner orifices. Then we're going to use the proper kit provided for this unit with propane. This is a Goodman unit. So it would be an 07 for this particular one. There's 06 and 08. You need to have the correct kit to do that. So once the burners are removed, we're going to put the The kit comes with enough burners to do 120,000, so that would be 5. You may have 2, you may have 3, you may have combination. Key point is to finger thread each one of these into the manifold. If you use a drill or a tool with a ratchet, it will or can strip the threads on these. These being brass and the manifold being steel, the brass is going to cross thread. If it does, you need to remove that one and start over again. And then when you're tightening them down, you use no Teflon, no pipe dope. The brass is designed to seal, so you will tighten them down a little past snug. Try to make sure that they are all even with each other, so don't have one super wrenched and then the next one really loose. Try to keep them all at the same measurement. And you have different tools you can tighten them down with, or a ratchet. Either way, we want them nice and snug and the same height. Then we're going to put this back together. When we do, almost all of them come with the ground wire. Remember to put that ground wire back onto the manifold body. If you do not, it may give you an error when you go to fire off the furnace by not sensing the flame properly. So it's very important that that green wire gets bonded back onto the manifold itself. Then next we're going to go into the gas valve itself. All the gas valves at some point are going to have an arrow in which way the gas flows. So the arrow will always point to the manifold so that you know which side of the gas valve you're going to set for line pressure from either the regulator on propane or the manifold from a meter on natural gas. So when we do that, the first thing we're going to do is we're going to match up our kit. And there's various different valves. There's White Rogers, there's Honeywell, there's Emerson, there's Gemini, which will be used with either Goodman or Rheem will have one of those styles of valves. They will send you the kit. With the Rheem furnace right on the cardboard box, the outside of the box, it will actually tell you which kit you need to use to convert it. So it might be an FP32 or an FP34. So right on the box of that. Goodman doesn't do it quite that way, but it's easy to call thermal and they can match up what kit goes to it. An 08 will go to a 96 variable speed, an 07 will go to a 96%er, and an 06 will go to an 80%. So on that part there, then this particular valve is a 2-stage valve. Almost all of the Goodmans, newer ones, are going to have multiple stages, 2 stages. And so this one has brass caps. They could be silver. When we convert over to propane, some of them may be black. It just depends on which type of valve you're using. In this here, so this is the little plastic set screw that holds the spring inside there, and is where we adjust the tension to adjust the water column of this particular gas valve for a high or low. The plastic is kind of a pain to get out. Once it's all the way screwed out, it doesn't easily want to come out. We need to be very careful that we don't mar or damage this part. Some of these we will put the same set screw back in. Other kits will have their own set screws and their own caps that'll either be black or they'll come with a washer. Whatever comes in that kit for that gas valve has to be utilized for it to operate properly. So on this one here, we're going to remove that spring, and some of them are silver, some of them are white, some of them are red, some of them are black. The key thing is that the propane spring is going to be a little tougher, have more resistance than the natural gas, because the natural gas works at a lower pressure. So when we take that spring out, we're going to put the matching one for that kit. So this one here, they send a White Rogers kit, they'll send a Honeywell kit, or an Emerson, or some version of a kit that goes in there. we need to take that spring that's designed for propane and put that in. These particular ones are white. So they will go in both the high stage and the low stage. And when we put the spring back in, and then we put the set screw in, we tighten the set screw down all the way till it bottoms out at the bottom, and then we're going to turn back 1 to 1.5 turns so that when we start out in a pretty neutral position with the spring not fully compressed inside of the valve. So again, we're going to tighten that rascal all the way down. And then when you feel it just barely stop, then turn it back 1 to 1.5 turns. Okay? So now we've converted the burners and we've converted the gas valve for propane. In the little packets, there's going to be little round LP stickers. Those are actually designed to go onto the set screw for the adjustment. And then it also has the warning stickers that go on the gas valve that it's been converted to propane. And with the kit comes this here. This needs to go on the outside so that it is visible for the inspector. The inspector must be able to see this at some point to know that unit has been converted to propane. So put right now on there, fill this out. Even if you don't take the time to fill out, at least put a sticker that tells the inspector and the homeowner that it has been converted to propane. Okay? Alrighty, so now that we've done all of this and we've put it back together, we're going to need to test the incoming, the inlet pressure, and the manifold pressure of what this is going to be adjusted for. Okay? So in propane, the minimum pressure that they want is going to be 11 inches, and the maximum is 13. Some I've seen up to 15 inches of water column. Natural gas is 4.5 or 10 inches of water column. Here's the key point. When we tie into this and put our meter on, we want to do the line side first, fire the furnace off, and make sure we don't have more than a 2-inch of water column drop from the incoming. If we do, if it becomes down to the minimum amount at some point or at the time of fire off, it may have an issue where it does not have enough gas supply to run the appliance properly and will cycle and shut off. So the first test in testing this, and there's two different styles really. So one takes a little brass barb, a little 3/8, and the other one for White Roger takes this little tube. It's next to impossible to see, but this here we can tell is on the line side. There's a little tiny screw that you use this Allen wrench on, and all you do is loosen that screw. You do not remove the screw, and once you loosen it, then you take this, which is provided in the LP kit, and you push it over the valve and make sure it's a snug, tight fit. When you're opening this up, this being on the meter or the tank side, it will dump gas as soon as you loosen that screw. So you need to turn the safety shutoff valve off prior to setting this up, and so that it makes a good connection. And then what you're going to do is you're going to take a manometer. There's various different forms of them, and you make sure obviously that it works. And then what you're going to do is you're going to attach that to this. Again, making sure there's good connection and no leaks. Because if you dump gas and it burns out improperly, it could have a rollout and a very undesired effect. So we do need to make sure that. So now that I am hooked up to the incoming from my tank or my meter side, I'm going to fire my furnace, making sure that the gas valve is turned on. And I'm going to confirm that with the newer ones, you have low fire and high fire, which it tells you on the 80%ers, on the it will be a 5-minute wait or an auto or something of that nature. And some start off in high fire and others start in low and then shift over 20 seconds later. They all have different sequences on that. But what you need to do is we need to make sure we're in high fire and that our rate of gas flow in inches of water column does not drop below the minimum. If at any point it drops more than two inches of water column, or definitely below the minimum, odds are we're going to have a problem. On propane, especially if we have a two-regulator system, there's adjustments to the regulator itself that can be made that can increase that pressure. Also, we need to confirm that there's gas in the tank. If obviously you're at 10%, that's going to show funny, and that will not set up properly. You need at least 20% to have a good tank pressure to do the rest of the adjustments on there. So once we have confirmed by firing, we're going to turn the gas off, leaving the furnace blower running so that we do not overheat the limits and you spend the next 15 minutes to half an hour waiting for those limits to cool down before you can do your next measurement or adjustment, okay? So with the gas turned off, we are going to take this off. And we're going to go to the manifold side and check our pressures there. We're going to take our Allen wrench, obviously, and we're going to tighten that down and make sure that it's not leaking. Now we're going to turn the gas back on. I do not recommend snapping the switch on the gas valve any more than you absolutely have to. It's a very inexpensive on-off switch, and I've had them where they've actually broke, brand new. So I would recommend always using the safety shutoff. And now we're going to go to the other side of the valve, which is right here, and we're going to do the same thing. We're going to loosen that, and then we're going to put our connector for this valve on it, and then we're going to hook this back up, and we're going to fire it back off again. And now is where our set points come in on high and low fire, and we have to do both of those. We have to do both high fire and low fire. Now, each unit, Rheem has it on the inside, the newer Goodmans have it on the door panel, but each one will have what the manifold pressure is supposed to be in high and low, what the temperature rise is supposed to be. It has all of that if from 0 to 4,500 feet in elevation, and where the adjustment is after that. Usually that's 4% per 1,000 feet of elevation. We deregulate, which means we'll turn this screw backwards to lower the pressure because there's less air the higher we go in elevation, and we need a good air to gas ratio for a proper clean burn, okay? So again, that sheet, which is in the booklets that are provided for every unit, will tell you natural gas and propane what the low stage. So in propane, low stage is going to be 5.7 to 6.3 with the nominal of 6. So it's right basically in the middle. In the middle of that is what they call the nominal, okay? You can adjust, but try your very best not to go below the lowest point setting. You may have intermittent ignition issues where there's not enough gas for it to burn off properly, which will come to the temperature rise section a little later on when you're finishing that. Okay, so first, whatever it starts with, if it's low, you set that low pressure between, so we're going to stay with the nominal, which is going to be 6 inches of water column and low fire. And for high fire, it's going to be 10 inches of water column. Okay? So we will make adjustments to these set screws, okay, plus or minus to make that. Now, there's a little bit of lag time usually for where it's going to end up. So when you make an adjustment, start slow, take it off, put your finger over the hole and confirm that it's staying true to the pressure that you have it set for. So you're going to do that for the low fire, and then also you're going to do the same thing for the high fire. So once you have those adjusted properly, you're going to put these caps back on. In the propane ones, if you're doing like the Honeywell one, it has black special ones that are non-venting that go in that particular place. So whatever comes with that kit, if it comes with set screws, if it comes with the finish screw, all of those are going to be used. If they just use the same top screw, but they send a little round gasket, that's designed to go on there to shut that off. And again, you need to put your finger over when you're doing the adjustment to make sure it's staying true. So now that you have all that done, again, you're going to turn the gas off and you're going to disconnect your meter. And you're going to take on that set screw and put it in and make sure it's snug. You're going to use a little bit of leak check and make sure you have no leaks on either one of those. The other style of valve that is most commonly used has the different barb. Same principle, different setup. So this one here, you're going to do the same program. It has an arrow on flow of which way the gas. So this is going to be the gas in. So you would remove this 1/4 inch, and then you're going to put the barb fitting in like so, and make sure it's snug because you don't want any leaks. Leaks are potential fire hazards. And then you're going to hook your meter up and do that same test for this style of valve. Okay, so when that's done on this part here, now these set screws can be a little more testy, so a very, very small amount of pipe dope can be used to help seal these up better. And then you're going to put this back in. Remember, this is an aluminum body, so you don't need to be He-Man and over wrench it, because you can crack the body and then the valve is no good. You're done. So once you do the inlet, and again, that's going to be the same settings. For propane, our minimum is going to be 11 inches of water column, and our maximum is going to be 13. It can go up to 15, but as long as it's not like 20 or something way off the charts, it's going to operate just fine. But we want to make sure that it does not drop below the minimum, and it really shouldn't drop more than 2 inches with full consumption of that. So then we're going to do the manifold side, and the same thing's going to happen. We're going to put our barb fitting in, make sure it's nice and snug, connect it up, and then we're going to set. This is a single stage, so we only will set just that one stage. So we'll take the cap off, and then we'll adjust that set screw, which makes the spring go up or down inside there. As you screw it in and down, the pressure increases. As you screw it out, the pressure decreases. And we're going to make sure we're going to stay into our specifications. That's either going to be on the book, in the book, or more than likely on the unit itself. So this particular one, we're going to look for 6 inches of water column, and that would be for low. This being one stage, we're going to actually just set this one at 10 inches of water column. Okay? So this is a Honeywell valve. Same principles. It has the 3/4 or the 1/4 inch barbs that go in it. Has a little bit different screw setup. This actually uses a star Torx, but they provide the star Torx. So all you do is loosen that out. You're going to use the new set screws, the new springs, and caps on this particular unit. Same process of the incoming pressure, same process of setting up the 2-stage valve on that part there. Okay, so now we're almost done, but the last step of this that you confirm, once you have set all your gas pressures on the nameplates of these units, again, it could be inside the furnace itself, or it could be, Goodman's now putting a lot of it on the door panel. In there, it's going to tell you the minimum and the maximum gas pressure adjustments and what's called the temperature rise. The temperature rise is the minimum and the maximum that this unit is designed to run at when it's gotten up to full speed. In other words, after about 3 minutes or so, the heat exchanger and all of that should be up to temperature. If it's extremely cold, it might be 5 minutes. But this is how we do this. We find out what the incoming air or the return air at the unit is. And you can use the thermostat, but if there's an issue of there's a leak in the return or something, so by the return, by the filter, as close to the unit as you can, you want to get your return temp. Then we need our supply temp. And our supply temp rule of thumb is this. It needs to be right out of line of sight of the heat exchangers. So we would not put it right below the coil, because that's going to radiate and actually make the temperature higher than it actually is. We need to be out of line of sight. So picture a duct run, and where it turns, as soon as it turns, that is going to get you out of the radiant of that, and that is the proper place to take the measurements for your temperature rise. So if we have 70-degree return air, most of these units, there are ones that are different, but most are going to be 30 to 60 or 30 to 55 or 40 or somewhere in that neighborhood. Again, that plate, door panel, will tell you what the temperature rise is max. So that means at 70 degrees coming in, if I'm out of line on my heat exchanger, I've been running for 5 minutes or so, and I take a reading and I'm 131 degrees, I am out of the temperature rise rate. I'm at 61, which is going to cause my furnace to overheat and thermal at some point. That means I need to go back and I need to adjust my gas pressure, put my manometer back on there, and drop the pressure down, let it stabilize for 5 minutes, retake my reading, and make sure that I stay within that 30 to 60 degrees. Now, I don't want to be any lower than that, because then my heat exchanger will not heat properly, and that can produce condensations and other things that can shorten the lifespan of the heat exchanger. So, overheating the temperature rise is hard on the heat exchanger, and also under. So we need to really stay within whatever the rating for that unit is for that. So if it says within 30 or 60. Now, if by whatever you can't get right close to inline, the next thing we do is we go to the closest register. And if we go to the closest register and you have 130 degrees at that register, and it's 70 degrees in the house, your temperature rise is too high, guaranteed. Because once you get to where the furnace is, it will be too high. So we will need to then go back and adjust the gas pressure down. And after we do that, we also need to make sure that our temperature rise for our low heat. On the newer furnaces, that's really nice with the app, is that you can run the programming down so it stays in low fire, or you can set it up right away 100% so it'll run, so you can adjust those very quickly. With the variable speed, with the switches, that takes a little more time to do that, but you can adjust that out. With the 80%ers, you gotta wait. That's just plain and simple. Every time you stop and start that, you'll have to wait that 5 minutes to do that. And again, while you're doing all these tests, you always want to shut your gas off before you just kill the power, or, like I said, especially on warmer days when you do this, you will be waiting 15 to 30 minutes for those limits to reset so that you can redo that. So just turn the gas off, let the heat exchanger cool down a little bit, and then carry on with your different tests. Okay? So just a quick recap. Very crucial that we put the sticker on the outside of the unit that is visible for the inspector, because you'll get a red tag if he doesn't find that. The other ones, the little round LP ones, go on the set screws for the gas valve itself, and then this one here is designed to go on the gas valve if you can't get a good location. Put it somewhere inside safe where the burners won't get to it, so that people know that it has been converted to propane. I recommend you keep all the parts and just leave them there for the customer, usually with the paperwork, so that if they ever get natural gas, that they can convert back over. And that's it for today.
Quick question, Don Rapp. From what I understand, we recently had a couple furnaces that, whether the LP kit wasn't put in or it wasn't put in properly, and correct me if I'm wrong, the heat exchanger actually got compromised at that point. Would you mind elaborating on that?
So what happens is, if you do not change the orifices, the natural gas orifice is larger than a propane orifice. So that means that the fuel to air ratio is going to be off. What that does is creates an unclean burn, and that unclean burn creates carbon, and then carbon starts starts plugging up the heat exchanger, and that creates hot spots on the heat exchanger. So over time, and not in most cases, not a lot of time, it will overheat that heat exchanger to the point where it will rupture it, and then it's compromised, and then therefore has to be replaced. The other part of that is if you're not doing the springs and using a manometer to set the gas pressure properly, you're over-firing. So even if you put the proper LP ones in, you're not adjusting the pressure properly, or you put the LP springs in and screwed them all the way down, but then didn't use the manometer to check them, because nobody's good enough to be able to do it by eyeball on looking at the flame and say, oh, that looks pretty good. That's the improper way to do it. The right way to do it is to put a manometer and then confirm that your inches of water column. Because again, if that's pushed all the way in and you're over firing at 13 inches of water column, you're going to exceed the temperature rise of 60 degrees on most furnaces, or 45 on some other ones, and you will compromise that heat exchanger within a few years max because of that.
Excellent, excellent. Well, anything else you want to add, or anything else?
Be a professional. If you don't have a manometer, get a manometer. Digital ones are nicer, because the yellow jackets, which I used for years and years, are fine until the first time you spring it, and then they're no good. So I use a water manometer. That's another way. I can zero it out. It works in any elevation, but that's old school. So most everyone uses the digital, which is the proper way to adjust these.
Excellent. Well, thank you.
Yep.
All right, guys. I did have we had Austin call all you guys and verify who had manometers and who didn't. Surprisingly, majority, if not all of you, have one, except for I worked one out with Isa, and it's on order. It should be here sometime today. Make sure you're using those on there. If you have any questions on how to hook it up specifically to the gas valve, I think he gave pretty good examples on how, but if you're still not quite sure how, I'm sure Mike Wolcom would be happy to share with you how to be able to get that on there. If not, I will. Make sure you're using them, okay? Any questions? Yes.
I occasionally run into a gas valve where it has the fitting right next to the pipe and you can't screw it in for the inlet. Is there an adapter one with a smaller square?
I'm not familiar with that. Mike, are you familiar with what he's talking about?
It's normally a Honeywell fit, so the inlet is literally right next to the pipe, and so you could screw it in, but not that far enough for it not to leak, because the square part where you would wrench it down rubs up right against the pipe.
I haven't ran into that. If you would, do we have one of those gas valves at the shop? Can you bring that into you, Mike, and have him bring that in? That's a rare thing. I haven't ever heard of that. Has anyone else ran into that problem on those?
Yeah, grind down the threads on your bar fitting, find that's the point to put your wrench on.
So you're running into the same thing, huh?
I took a grinder and ground it down. So I don't use a wrench to tighten it up, I use my fingers and tighten it. It's pretty tight, the main manifold bar curves, so if your bar fitting's too big, you can't get it in.
Okay. Well, news to me. That's on the inlet side? But you have no problem getting it on the outlet side? It's on the outlet side. On the curve coming out on the outlet side. Okay. Can you twist the gas valve on the manifold a little bit to get it out of the way? Okay. Any other questions? Excellent. Have a good day, guys.